All right, so now we're going to take what we've learned about derivatives and how the graph of the derivative function relates to the original function. And we're going to apply that with a couple of fun little game sort of things. These are from the GeoGebra, or the Shippensburg University GeoGebra applets here. So this one here gives us the graph of a function f on the left. So this blue curve here is our function f, and we're supposed to identify from the other graphs, among these other three graphs, which of these is the graph of the derivative of f. So how do you do this? Well, one way you can do it is to try to figure out like where it would cross the x-axis. So this graph on the left appears to have a horizontal tangent line somewhere right down about here. You're looking for the point at the bottom of the curve where it reaches its lowest point, where it's basically horizontal. To check the x-axis, that would be about between -1 and -2. So we're looking for an x-intercept over there. So it looks like that's going to narrow it down to, well, this one has an x-intercept over here between -2 and 3. That's possible. This one also has one between -2 and 3. The green is between -1 and -2 right there. So, okay, let's get a little more information. It also looks like it is reaching a horizontal tangent line way over here on the right-hand side. So we should have an x-intercept over there. Well, it looks like the green one and possibly the red one have x-intercepts at the point where this would be reaching a horizontal tangent. The brown one does not, right? So there's that, and then there's no another piece of information we can use is there's no other point in between these where the tangent line would be horizontal. So our graph should not have any other x-intercepts between these 2 points we've identified, which actually rules out red down at the bottom here because this has an x-intercept between 2 and 3, and yet our graph clearly doesn't have a horizontal tangent line between 2 and 3. So using this information, you can rule it out and figure out that it's the green one here and click on that. We could also have been using information such as between -2 and 6 or whatever. This should be positive all the time because we can see the graph increasing on that entire interval. So the derivative should be positive, which is the case. The derivative graph is above the x-axis here, right? We could have ruled out brown by noting that it is a negative derivative value at 0, whereas here at 0, it's pretty clearly increasing the original function, so it should be a positive derivative value. And we can rule out red by noticing that here at 5, it has a negative derivative value. So the original function should be decreasing, but our original function is actually increasing instead. So that's the kind of logic, sort of graphical reasoning you can do. And this, you can reset it, and you can do this over and over and over again with different examples, just to test yourself. And if you check and it's wrong, it'll tell you no. And if you check until you get it right, it'll tell you the right one. So there's that, and I'll send you a link to this. And another sort of similar exercise is to attempt to draw the derivative of a graph. So here is this black curve here is our graph f, and we want to attempt to draw it. So we're going to look and see where the axis intercepts are. Like here is an axis. Here is where we should have an axis intercept because we have a horizontal tangent. Down at the bottom over here, it looks like we should have another one. So I'm going to pull this up. So we should have an x-intercept somewhere over here. It looks like it's going to be decreasing on this interval here. And at this point here where I've got my cursor, that looks like about the steepest point on that segment. And I would say that slope is about -1/2. It's not quite a slope of -1, which would be like, down 1 over 1. That is a shallower slope. So I'm going to pull all these points way up here so that the smallest value reached is about -1/2 right there. Over here, let's look for a spot where the slope appears to be about 1. I would say over here at 5, it looks like it's about 1. So I'm going to place that at 1. And I'm just going to adjust these so that they kind of, I don't know, do something like that. Whatever. I'm not really sure. That looks fine. So I've got it looking okay all the way over to here. It's going to hit 0 somewhere about there. Right at 0, the graph appears to have a very gentle slope of maybe positive 1/2. I'm going to put it about there. And and it doesn't reach a slope of more like the 45-degree angle. It doesn't reach that slope of 1 until maybe over here about negative 1.5. So I'm going to adjust these so that it does that. And this is a positive slope on this segment here. So that's correct, that it should be above the x-axis. And its steepest point is somewhere in the middle at what we call an inflection point there. That's where I want my derivative to reach its maximum height. That looks pretty good. I maybe want to adjust the location of this x-intercept so that it's a little bit more so between -3 and -4, right where that reaches a minimum. That's where the horizontal tangent would be. And then over here on the left side, it's got a negative slope, which is correct. So it should be something like this. So now that I've adjusted it, let's check the accuracy. It says I'm 89% accurate. That's pretty good. And if I click show result, there we go. That red curve is the exact derivative, and I was pretty close. So I hope that this explanation helps illuminate some of the connections between the graph of the derivative and the graph of the original function. You can estimate what value the derivative should have just by looking at estimating the slope of the graphs of the original graph. I recommend going to this website and just trying this out. And with some practice, I think you will develop a nice understanding of the derivative in a graphical way that will really give you like a solid foundation for understanding other things about derivatives and rates of change. So, here we go.